My name is Wesen Gannon. I'm the Global Product Manager for Electric Products at Bray. I would like to introduce you to the Series 76 Industrial Electric Actuator. This heavy-duty quarter-turn actuator designed for on-off and modulating applications for all industries. The Series 76 electric actuator is available in single-phase, three-phase, and DC power, and comes with an optional local control station. This range of actuator is suitable for butterfly, ball, and plug valves, as well as damper control. Today, Jason is here to walk us through setup and calibration. Jason?
Hello, I am Jason Dollenberg, Engineering Manager of Electric Products at Bray. It is important that you understand how to properly set up and calibrate the Series 76 Industrial Electric Quarter-Turn Actuator. We have taken proper measures to safely demonstrate these products. With that in mind, let's get started.
The tools required for this demonstration are as follows: a size 1 screwdriver, 4, 6, and 10 mm hex keys, a multimeter, and a loop calibrator. See the IOM for a full list of basic tools. Use all PPE required for the procedure and job site. Warning: the actuator must only be installed, commissioned, operated, and repaired by qualified personnel, and must be performed under strict observation of all applicable codes, standards, and safety regulations. Qualified personnel are defined in the Installation, Operation, and Maintenance Manual in Section 2. Section 9.1, Actuator Lifting. To ensure safety, proper lifting procedures should be followed. The size 5 actuator may be lifted with straps wrapped below the main body and gearbox. Size 6 and 7 actuators are fit with 2 lifting eye bolts. Refer to the Series 76 IOM, Section 9.1. We will demonstrate the hand wheel assembly, which is found in Section 8.1, Manual Operation. When you first unbox your Series 76 electric actuator, you will find that the hand wheel is unattached within the box. For the purposes of this demonstration, this will be assembled next but would typically be performed after you inspect the unit. First, remove the pre-attached hand wheel bolt and washer. Align the hand wheel with the double D shaft and mount. Replace the washer and secure the hand wheel with the bolt. Ensure that the hand wheel fits tightly to the shaft and freely rotates. Afterwards, the D-clutch may be tested to demonstrate manual operation. The indicator will rotate during manual operation. Note that power must be supplied to the actuator to disengage the manual mode. The next item that you should notice is the nameplate location. You should ensure that the nameplate, part number, and voltage match the actuator on your order. Note that for this demonstration, this unit has been pre-wired. This is a 110-volt single-phase on-off unit. We also have 3 3/4-inch NPT conduit entries, 1 on the left and 2 on the right. Note that this is a special conduit entry for mounting a local control station. The next item you should notice is the bushing. The standard bushing supplied is a blank S45C carbon steel bushing. There's also the option to have this pre-machined by the factory for your needs. To uninstall the bushing, remove the 2 machine screws and then draw the bushing out and machine it to your requirements. This bushing also can be rotated 90 degrees to rotate the mounting pattern. We will then take off the cover and show the internals of the actuator. Note that the cover screws are captured in the cover itself. We have pre-wired this actuator. I'll demonstrate how to properly wire the ground. Insert a screwdriver into the top hole and press down to disengage the spring. This will open the terminal entry for wire removal or installation. Once the terminal is open, you can push the wire in and then allow the spring to re-engage and clamp on the wire. Tugging on the wire will demonstrate that the wire is secure in the terminal. We will demonstrate how to adjust the cams, which is found in section 9.7, setting travel limit switches and mechanical stops. Adjusting the fully open and closed limits is a simple procedure. Manually operate the actuator to the desired closed position. Loosen the cam screw and rotate the cam until the limit switch activates. Retighten the screw. Test to ensure that the limit switch activates at the desired position and adjust if necessary. Repeat for the open limit switch. Refer to the IOM for the full procedure, which includes adjustment of the travel stop bolts. We will power the unit and demonstrate proper operation. It's now moving in the open direction. While it's moving in the open direction, it is a good time for us to demonstrate the operation of the torque switches. Activate the torque switch to simulate an over-torque event in the open direction. Note that the actuator is able to operate in the closed direction. The actuator will allow operation in the opposite direction of the torque fault. Section 8.3. Modulating operation with modulating control card. We are looking at a modulating control card for the Series 76 actuator. A 6-character, 14-segment LED display is used to control various control menus and settings. Shown here is a 4 milliamp signal commanding the actuator to the fully closed position. The display shows that the actuator is stopped at the closed limit. The display alternates between the operational status and the actuator position in percentage. We will demonstrate changing the actuator's position by changing the command signal from 4 milliamps to 20 milliamps. You can see the position on the LED display changing rapidly as it travels to the fully open position. You can also see the feedback signal as it follows the LED display. We have now reached the fully open position, and the LED display shows 100%. We will now demonstrate changing the command to a mid-travel position, 12 milliamps. You can see that the feedback is very close to 12 milliamps, 11.97. We also show 49.6% on the LED display. The actuator has repositioned within the tolerance for a 3% deadband setting. The deadband setting may be adjusted to help with positioning when required by the application. I'll now demonstrate auto-calibration. This is a very simple procedure that can be run from any position. There is an auto-calibrate button on the far bottom left under the display. Hold it for 3 seconds to start the calibration routine. You'll see the LED display A-scan interposed with the direction of travel during calibration. The routine will automatically exit into run mode once calibration has been completed successfully. It has reached the close limit. Now we're going to the open limit. Note that the feedback signal matches the position of the actuator during this operation. If the cam positions were modified, the feedback position may be skewed until the auto-calibration routine has completed and updated the settings. We have now successfully completed the calibration routine and returned to run mode. The actuator is now responding to the input command signal, 12 milliamps. Well done, on the dot. Now we're going to demonstrate the menu mode. We can enter the menu mode by pressing the mode button for 3 seconds. We're now in the Setup menu and we can see the first menu option. Set FS configures the fail position on loss of command signal. There are various menu options that we run through quickly. Set SP and Set FB are two critical settings to update for the application. Set SP defines the input command signal type and Set FB defines the feedback signal type. Select the Mode button to enter into the Set SP menu. The command signal is currently set to 4 to 20 milliamp mode. We can set the input signal type to 0 to 10, 2 to 10, 0 to 5, 1 to 5 volts, or 0 to 20, and of course back to 4 to 20 milliamp mode. To exit, hit the Mode button once. If we had changed the input signal type prior to exiting, the signal type would have updated. We're now going to exit the menu by holding the Mode button for 3 seconds. All menu options can be found within the Modulating Control Card IOM. Section 8.4, Local Control Station Operation. We will now demonstrate a 460-volt 3-phase unit with an LCS local control station. The electronics are installed within the control station. This differs from our standard modulating unit in that the modulating control card is embedded within the local control station itself. We will open the cover to highlight the differences within the actuator. Note that the modulating control card is not installed in the body of the actuator. We are in the stop mode. In this mode, the actuator will not respond to local or remote commands. We command 4 milliamps or full close position while we are located at the fully open position. Per our expectations, the actuator is not responding to the remote command signal. We will then operate the local open and closed command buttons to further demonstrate the stop mode. Note that the actuator does not have to be fully open or fully closed. It can be stopped at mid-travel. We'll now move into the local mode and command the unit to the closed position. Notice that the LED is flashing green under the closed icon. A flashing green LED indicates that the actuator is moving in the closed direction. When it reaches the fully closed position, the closed indicator will turn solid green. Also notice that the feedback signal, changing from 20 milliamps to 4 milliamps, remotely indicates the position regardless of the mode. The LED has gone to a solid green light underneath the closed indicator. We will now command the actuator in the open direction. Notice that the open LED is flashing red as it moves in the open direction. It will continue to flash until it reaches fully open, and then it will turn solid. Also notice that the feedback signal is changing from 4 milliamps to 20 milliamps. Now we will demonstrate the remote mode. Previously, we commanded 4 milliamps, which the actuator was not responding to because it was in the stop and local modes. Now we're going to change the local control station to remote mode, and it will start to respond to the 4 milliamp command signal and drive the actuator to the fully closed position. Note that the remote LED flashes blue while in this mode. The feedback signal is following the 4 milliamp command as it travels closed. We will demonstrate operating the local command controls at the same time. Notice that it does not respond in either direction to the local command buttons. We've now reached the fully closed position and the closed indicator is showing a solid green light. We will now change the position to a mid-travel 12 milliamps and demonstrate what happens to the feedback signal. We have now reached the mid-travel position. If remote-mounted control is required for the application, Then field wiring may be implemented by wiring to auto, stop, open, and close control terminals. In case the customer wants to implement this control option, wire jumpers must be removed from terminals 5, 6, and 9. These jumpers are automatically provided and are necessary to operate the local control station if remote-mounted control is not implemented. See the wiring diagram provided with the local control station for full details. We hope you found this video useful in getting you started to set up and operate your Series 76 electric actuator. Visit Bray.com for marketing and technical support documents. Should you need further support, please reach out to your Bray contact for assistance.